In this video, I'm going to talk about how you do dilution and titration calculations. Remember that we're talking about solutions, which are made up of a solute that is dissolved in a solvent. And the concentration is really just the measure of the amount of solute that is in that solution. Concentration as a word by itself doesn't really tell you anything, except that things that are more concentrated have more stuff in them, more solute is in the solution. A more useful measurement is a measurement of molarity, which will measure how many particles or how many moles of a substance are available in that solution, and those moles of particles then of course can participate in a chemical reaction. If you remember from the previous video, molarity is calculated by taking the moles of the solute and dividing it by the liters of solution, and you do need to turn your measurements into liters if they aren't already in liter form. So again, just to give an example, if you have 6 moles of solute that's in 3 liters of solution, you'd have 6 moles divided by 3 liters. The word per just means divided by, and then 6 divided by 3 is going to give you an answer of 2. So we'd say the molarity is 2. If you add more solvent to any particular solution, then the number of moles that are present in that solution will not change, but the volume is going to increase. So it's going to decrease the density of those particular particles that you're interested in. So if you look at our first solution here, we have a solution of iodine, and it has these little purple molecules, shows you how many are present. So in this particular measurement, we can see 5 different molecules of the iodine, but over here, after it's been diluted, after we've added more solvent, we are only able to view 1 molecule of iodine in that same volume of solution. If you take the math, you take something that has a molarity starting off with a 0.05, and after the dilution happens, we have a lower molarity of 0.01 molar. So whenever you have a question about a dilution, you're going to be calculating a new molarity by using the dilution equation. And that equation says the molarity of your first solution times the volume of your first solution will be equal to the molarity of the second solution times the volume of the second solution. So these are all multiplication relationships of molarity and volume. Now in these problems, it doesn't matter that if your substance is in liters or milliliters, as long as both sides of the equations have the same volume unit. So you don't have to do any conversions to milliliters into liters. If everything's in milliliters, you can just leave them that way. So here's an example problem. It's asking us for the new molarity of a solution. If you take 100 milliliters of a 2.0 molar hydrochloric acid solution and you dilute it down to a volume of 500 milliliters. So you're adding more solvent in there, but you're going to be spreading out how much hydrochloric acid molecules are available in any amount of that, and so we have a dilution being made. So to use our formula, our molarity of our starting solution, our stock solution, with 2.0 molar, our volume is 100 milliliters, and that will be set, 100 milliliters, that'll be set equal to our unknown molarity, what we're going to solve for, times our volume, which is 500 milliliters. So if you go ahead and do all the math here, you will find out that your molarity will have become 0.4 molar. So we've gone from 2.0 molar down to 0.4 molar. This is a more diluted solution, and this is actually something you do quite often in chemistry lab, where you're working with a more concentrated stock solution, and you use that to make the dilution with the particular molarity you need for your reaction. Here's another problem where you're having to figure out x will be a different value. This one's asking you how much of a 16 molar stock solution, and that's a very concentrated solution, would be needed to make 800 milliliters of a 0.5 molar nitric acid solution. So again, this happens in the lab. You get a small bottle of a very concentrated acid solution, then you have to make the amounts that you need for your experiments. So our initial starting solution is going to have a 16 molar molarity. We don't know how much we're needed. We're asking how much is needed. Our final solution, our dilution, we wanted to have a 0.50 molarity, and it will have, we want 800 milliliters of that. So we're asking, what small amount of volume of this very concentrated solution do we add some solvent to it so that we'll end up with our 800 milliliters. Again, if you do the math, multiplying both these things and then dividing both sides by 16, you'll find out that X is going to equal 25 milliliters. So in order to make this solution, you would start with your 25 milliliters, and then to that you would add your solvent. Usually it's enough water to make your final volume, and our final volume is going to be 800 milliliters. So you just need 25 milliliters of this very concentrated acid, add enough, 775 milliliters, and so you end up with 800 milliliters of total solution. We use a version of the dilution equation when it comes to neutralization reactions. Remember that an acid can be neutralized by a base. It basically can be canceled out, so it's no longer an acid, or a base can be neutralized by an acid, so the base is no longer a base. In the acids and bases that we have been dealing with in class, we see that it's a hydrogen ion from the acid combining with a hydroxide ion from the base to form water. And of course, water has a neutral pH, and so that's where the name neutralization reaction would come from. The moles of hydrogen ions and hydroxide ions must match exactly to make the pH of 7. If you have a little bit more of your acid ion there, your hydrogen ion, then it'll remain a little bit acid, or if you have too many hydroxide ions, it'll be a little more basic. So in order to end up with this neutral pH, they have to match exactly. You have to have just the right number of moles of hydrogen ions and hydroxide ions. We use this principle with a technique called titration, which is a method for determining the concentrations of an acid or a base, or actually a number of other substances are tested by titration. This is an important technique for industry to make sure that the concentration of the finished product is exactly what it's supposed to be, and so quality control will be checking on the various chemicals by using titration. If you're talking about an acid and a base, you will have a neutralizing substance. You've got, say you're working with a base and you're trying to figure out the pH or the concentration of that base. Well, then you will know the concentration of the acid, which is going to be what will neutralize it. So you have one substance with a known concentration, one with an unknown. You need a pH indicator, which will tell you when that neutralization has occurred because it will change color at just the right time. And then two other words that we often see when we're talking about titration is the equivalence point, which is when you do have that perfect match between hydrogen ions and hydroxide ions, and then an end point when you actually have your indicator changing color. This picture here gives you an example of somebody doing a titration experiment. We have this unknown sample. It's an acid. We don't know what the molarity is, for example, in particular. We do know the molarity of our sodium hydroxide, which is in this long skinny tube called a burette. And you have a little handle down at the end where you can let a little bit in at a time, little drops at a few drops at a time. And so then you have your pH indicator inside the unknown acid, and you can see down here a little bit of color change happening as the sodium hydroxide is being added. You mix it during the process, and when you get to a point where the color change has happened fully through the solution, you know that you have reached the end point. You have equalized, neutralized the unknown acid by adding the amount of base. Since you know the concentration of the base, you can calculate then exactly what is the concentration of the acid. So to do those calculations, you just use the dilution equation, but with a little bit of variation. Instead of saying the molarity of the first substance, we say the molarity of the acid times the volume of that acid is going to equal the molarity of the base times the volume of the base. So instead of molarity of first solution and second solution, here we have A for acid and B for base. So to just give you an example, the chemist determines that 20.7 milliliters of 0.5 molar sodium hydroxide is required to neutralize 15 milliliters of hydrochloric acid. What's the molarity of the acid? So again, we're being asked to figure out the molarity of the acid, so that will be our X. We know our volume of our acid being 15.0 milliliters. We have a known molarity for your base, 0.500 molar base times 20.7 milliliters. Since it's milliliters on both sides, I don't have to change any of the units. Again, you'll multiply these two together, divide everything by 15. Doing the math, basic algebra, we'll come up with an answer of molarity. Actually, X will be the molarity answer, 0.69 molar. So the molarity of this 15 milliliters of hydrochloric acid has been determined to be 0.69 by this titration experiment and a little application of the formula. Just another example, if it takes 12.5 milliliters of a 0.3 molar hydrochloric acid solution to neutralize 285 milliliters of sodium hydroxide solution, what is the concentration then of that sodium hydroxide solution? So here we're just looking at the concentration of the base. Again, you're just plugging in the numbers, so we've got 12.5 milliliters, actually I put this the wrong way around, 0.30 molar times 12.5 milliliters, so our molarity of the acid, the volume of our acid, is going to equal our unknown molarity of the base times the volume of the base, 285. Again, it's milliliters on both sides, so I don't have to do any kind of conversion. Again, multiply on this side, divide by 285, just basic math equations here, and it will get an answer of 0.0132 molar for our sodium hydroxide. Actually, we just have two significant figures here, so 0.013 molar would be a better representation. So that's just showing you two ways to use this equation for dilutions to calculate molarity or volume for either your stock solution or your final solution, your diluted solution. And again, in titration equations to look at what's our molarity or our volume for acid, and then the base when you have a neutralization reaction happening. You'll have a chance to practice this, of course, on worksheets. I think you'll find this is pretty straightforward, not like some of the other calculations we've had to do recently.